Continuing the tape on derivative of function, we will now look at the concept of the product rule. The product rule. Now, what I hope that you will notice is this. The derivative of a product, some object times another object, is write the first object down, and now you take the derivative of the second object. Remember in the other tape I said this says the derivative of whatever v is with respect to x. Well, v is the second object. Plus, then you write the second object down and take the derivative of the first one. This is saying the derivative of the first object, the first quantity over here, with respect to x. Now pay close attention to what this rule says. Number one, it says this. You cannot take the derivative of more than one object, concept, parenthesis, expression, term, whatever it is. You can only take the derivative of one at a time. You must write one of them down, take the derivative of one at a time, and then continue taking the derivative of the other one. Read the notes that I have right underneath this and get in mind what I'm saying about the product rule. The product rule says this. Write, if you have the derivative of something times something, you write the first one down, take the derivative of the second one. Plus, write the second one down, take the derivative of the first one. Now, it's really not necessary that this is first and second, second first, that concept. It is the concept that you can only take the derivative of one object at a time. So if you have two or more objects here multiplied together, you must only take the derivative of one at a time. Let's look now at the three examples, number 12, 13, and 14, to express what this rule says. Looking at example 12, we have y equals the parenthesis, the object, x squared plus 1, times the object, 2x minus 3. Now, if you'll remember in your notes, or if you'll look back on the notes to example 5, in the previous tape, back a page or two in your notes, you will notice that what we had to do on a problem like this is to multiply it out and then take the derivative. Well, now with the new rule, the product rule says, I write the first object down and take the derivative of this one. Just look at this and take the derivative. The derivative of 2x is 2, remembering? The derivative of bx is b. The derivative of constant is 0. So the derivative of all this parenthesis is 2. I write the first object down, take the derivative of that. Then plus, write the second object down, the second parenthesis, the second product concept, and take the derivative of the first one. Now the derivative of that is what? The derivative of x squared is move the 2 down, subtract 1, that would be 2x. The derivative of constant is 0. So this is 2x plus 0. And that's it. That is the product rule right there. The rest of the problem is simplification. Multiplying the 2 times x squared, we get 2x squared. Multiplying the 2 times the 1, we get plus 2. Multiplying 2x times 2x, 4x squared. Multiplying 2x times minus 3 is a minus 6x. And then simplifying, we get the same answer that we got in example 5. Now, this is it, and this is all there is to it. All you've got to do, we're not taking any more derivative rules in terms of power rule, whatever. We're saying simply this. You write the first one down, go take the derivative of this. Use the last tape's concept, just derivative. Derivative of this, derivative of that, you write it down. Then you write that one down, and then you take the derivative of the first one, just as if that was all there was to the problem. And that is the product rule. Remembering what it's saying is you cannot take the derivative of more than one object at a time. There are many students that will come up here and say this answer is 2x times 2. They'll just take all of it at one time. And what I'm saying is the product rule says if you have a quantity times a quantity, you can only take the derivative of one of those quantities at a time. So you must write the other one down, take the derivative of that quantity, then write the other one that you hadn't written before down, and take the derivative of the other quantity. Study that example for a moment before we go to the next example. And that is how simple the product rule is. The remaining other two examples are just going to be going over that same idea and showing the algebra that's involved with a lot of your homework problems. Okay, let's go down to example 13. Example 13 has y equals the square root of x times the quantity x squared plus 2. Now I realize that on this problem you could multiply it out just like the other one and get the same answer. The reason I'm doing this example is to get across the product rule. Not saying this is necessarily the best way to do these, but just to get across the concept of product rule. Now the product rule says this: if I have a quantity times a quantity, I will write the first one down, take the derivative of the second one. The derivative of this is 2x to the first power plus 0. So I write the first down, take the derivative of the second one is 2x. Plus, I write the second one down and take the derivative of the first one. Remembering this is x to the 1/2 power, so the derivative of that would be 1/2, and then subtracting 1 gives me a minus 1/2. Alright, the remaining part of this problem now is something that you must learn. And that is, this one, we'll just leave it as it is right now. And this has a negative exponent, so we'll move it down to the bottom. That would make x to the plus 1/2 on the bottom, which is the same thing as the square root of x. And the 2 is already down there. And so we have x squared plus 2 over 2 times the square root of x. Now we get a common denominator. Getting common denominator, we multiply this times that. So 2 times the 2 would be 4. And the square root of x times the square root of x is x. Times x is x squared. Plus this numerator, x squared plus 2. All over the common denominator. And then grouping, adding the x squares together, we have now simplified as 5x squared plus 2 over 2 times the square root of x. I don't want you to miss out on this, because there are many homework problems where you have to do all this algebra. It is important later on when we get to application. As I said in the tape before, we're going to learn how to set this first derivative equal to 0 and find maximum minimums or stated problem answers, that type of thing. So we must learn how to take care of this algebra. You might as well learn it now, get used to it on these kind of problems, so that it will not have to be discussed or explained in class when we get to the stated problems of the graphing. Alright, let's go now to example 14. In example 14 here, we have y is equal to 3 quantities squared. And so this product rule is saying the same thing no matter whether we have 3 quantities multiplied together or 4 or 5 or 2 or whatever. What it says is you can only take the derivative of one quantity or object at a time. So that says we will write down the first 2 and take the derivative of the third one. The derivative of 3x is 3. Derivative of 5 is 0. So here is the derivative of that one. Plus, now I'm going to write down another 2. Looking back at the original problem, I'm going to write down now this one and this one. And that means I'm going to take the derivative of that one. You see, what I'm really going to do is I'm going to write these 2 down and take the derivative of that one. Then I'm going to write these 2 down and take the derivative of that one. Then I'm going to write these 2 down and take the derivative of that one. The concept of the product rule is I can only take the derivative of one quantity at a time. All right, looking back now in the middle of the answer, I'm writing down the first one and the third one, and here's the derivative of the middle one. Derivative 2x is 2, derivative minus x cubed is minus 3x squared. Plus, now I'm going to write down the second one and the third one and take the derivative of the first one. So writing down the second one, the third one, and the derivative of the first parenthesis is 2x. Now, we will leave problems like this at this point, because the purpose of this kind of problem is just to make sure you understand the concept of the product rule. If you were having to work this one out to find it equal to 0 or something else, then you'd end up having to come back and look for factors, common factors. If there are none, then you're going to have to just multiply all this together and multiply all the x's and parentheses together, and then group all the x to the fifth powers and fourth powers and so on, and then work it from there. The purpose of this kind is to point out the fact that back in this problem you can only take the derivative of one at a time. And if you have two or more product, then you can only take the derivative of one at a time. I hope that you will listen to what I'm saying in terms of the derivative one at a time. Too many students will try to take the derivative of all that at the same time. All right, those are the examples then that cover the concept of the product rule. I hope you will study those carefully in terms of concept and not just the answers that I have. Yes, you need to know how to do the algebra that's involved. But more than that, you need to understand the first step. This is the calculus product rule. From there on, it's algebra. All right, let's go to the next rule. The next rule is called the quotient rule. And it simply says, what do you do about division? Now, we just got through talking about what you do about multiplication. Now, what do you do when two objects are divided? This rule says this: the derivative of a division problem is, all right, watch. I write the I write the denominator down times the derivative of the numerator. Minus, then I write the numerator down and take the derivative of the denominator. Then all that is over just the denominator squared. No derivatives down here. Just write over whatever that denominator down, square it. Okay, so let's look at this one more time. It says, denominator times the derivative of the numerator minus numerator times the derivative of the denominator, all divided by denominator squared. Again, read the notes right underneath that. Read it carefully. Memorize it. Either memorize that concept in your mind or memorize the words that I have underneath that in the notes. All right, let's look now at example 15 and follow those notes. Here we have y is equal to 3x squared over x to the fourth minus 5. I have a division problem, a quotient rule. I have some object divided by some object. The rule says write the denominator down, take the derivative of the numerator. Derivative up here is 6x to the first power. Minus, write the numerator down, take the derivative of the denominator. The derivative of the denominator is 4x cubed minus 0. 4x cubed. All that over the denominator squared. It's just a memorization process, and it is not that difficult if you'll memorize it word by word as I have it in the notes. Write the denominator down, take the derivative of the numerator, minus, write the numerator down, take the derivative of the denominator. Just learn that you cannot take derivatives of more than one object at a time. And if you will remember it that way, Then you remember the quotient rule says write one down times the other one plus write the other one down times the other one. The division rule says denominator times derivative of the numerator minus numerator derivative of the denominator all over denominator squared. Well, finishing this is the algebra. 6x times x squared is 6x cubed. Oh, I'm sorry. This is what my mistake is. This is supposed to be x to the fourth. And so that does make it 6x. I'm sorry. Back here, if you'll notice, I'm supposed to have the same thing. This is x to the fourth minus 5. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. And multiplying this is 6x to the fifth minus 30x minus 12x to the fifth. And so we have this adding together, and we have our final answer. All right, let's go to the next example. Example 16. Again, these are just examples to teach the rules. We have y is equal to x squared minus 1 over 2x plus 1. I write the denominator down and take the derivative of the numerator. The derivative of the numerator is 2x plus 0. So that's 2x. Minus, I write the numerator down. I take the derivative of the denominator. The derivative of this is 2 and then 0. So that'll be 2. All over the denominator squared. Okay, again, go over it one more time. If I have a division process, it's write the denominator down, take the derivative of the numerator, minus, write the numerator down, take the derivative of the denominator, all over denominator squared. Now, if you'll listen to me, I would advise you to do it exactly the way I'm explaining it. There are students at times that will square this, write it down, and then when they start talking about the denominator, they look here. But what I'm saying is the rule says the denominator originally, the original denominator, you write it down, you take the derivative of the numerator. Then you write the numerator down and take the derivative of the original denominator. All over, then square the denominator. Don't do it first. All right, simplifying then, this was 2x times this would be 4x squared plus 2x minus 2x squared minus times minus plus 2. Simplifying all that, you get that. All right, example 17. Example 17 has y is equal to the square root of x over x minus 1. Here again is another example of the rule. This is what we're looking for, the rule. And then the rest of the problem is going to be helping you with your algebra, if you need it. All right. We write the numerator down and take the derivative of we write the denominator down, take the derivative of the numerator. Now this is x to the 1/2, so that's 1/2 x to the minus 1/2. Minus, write the numerator down, take the derivative of the denominator. Derivative of 1x is 1, 0. All over the denominator squared. Now, watch the algebra. This is all divided by x minus 1 squared. Just this part right here is x minus 1 over 2 times the square root of x. This is a negative exponent. We'll move it down underneath. But that's still all on top of this main division sign. Minus the square root of x. Now, getting a common denominator for this numerator up here is x minus 1 minus 2 times the square root of x times the square root of x. Square root of x times square root of x is x times the 2. Then you should be able to see what I have here. If I have this divided by this divided by this, then I'm dividing this by this and this. So both of these become a denominator. You can do it that way, or you can take this over 1, invert and multiply, and you get the same thing. Or you can know the rule that says when dividing a fraction by a fraction, it's the numerator of the numerator times the denominator of the denominator all over the denominator of the numerator times the numerator of the denominator. That's the way I learned it. All right, let's go to example 18 and work it. Now, 18 is a case where we do not have a division problem in respect of x's up here and x's here, but yet we still have a division problem. It's this divided by this. And we don't have any other rule that if we have any kind of division, whether it's x's or what, we don't have any other rule. So we'll have to use this concept of division at this point. The last part of this tape on the chain rule, I will show you how to work this same problem a different way. All right, so I write the denominator down and take the derivative of the numerator. Derivative of a constant is 0. Then minus, I write the numerator down and take the derivative of the denominator, which is 3x squared minus 10x, all over the denominator squared. And then, of course, 0 times this is going to wipe that out. And so we have minus 3x squared plus 10x over the denominator. Okay, here again are some example problems of showing the concept of the division rule. Let's go back and look at it now. There is not an extreme amount of difficulty in learning this if you will learn two concepts. Number one, you can only take the derivative of one object at a time. Number two is then memorize this rule, which says, since you can only take one at a time, here's what you do. You write the denominator down, and you take the derivative of the numerator. Minus, you write the numerator down, you take the derivative of the denominator. All over the denominator squared. If you will take this process as a single concept, it will not give you as much difficulty. If you try to look at a problem, looking back at 15, if you try to look at a problem here and just start saying, okay, well that's 6x and that's 4x cubed, then you're going to get yourself fouled up. If you have a division process, then you must remember the division rule, which is write the bottom one down, take the derivative of the top one, minus top one, take the derivative of the bottom one, all over the bottom one squared. Looking back at example 13, we have a product. Okay, remembering I can only take the derivative of one at a time. So what I do, if it's product, then my second concept is the rule. Write the first one down, take the derivative of the second one, plus write the second one down, take the derivative of the first one. Thereafter is algebra, and this is going to give you a lot of trouble, the algebra in these problems, to be able to match your answers with the answers in the back of the book. But make sure, please, that you get these concepts of product rules and division rules. All right, now let's go to the last part of this tape and discuss the chain rule. All right, the last part of this tape about the chain rule, an extremely, extremely important concept that you will use over and over and over again. The chain rule says this. Now watch closely and don't just look for a final answer. The chain rule says if I'm taking the derivative of an object, now it's not the same now. If I'm taking the derivative of an object raised to a power, then it's the power rule that we've learned before times the derivative of the object. Now, we have actually done that before. When we were taking the derivative of x to the 6th, that is 6x to the 5th times the derivative of this object. Well, the derivative of x is 1. See? So we just kind of automatically did it all those other times. I am not saying we have a brand new thing here. I am saying that when we take the derivative of an object to the power rule, it is the power rule times the derivative of this object right here. Looking right below this, the example says, if I'm taking the derivative of an object, I use the power rule on the object. Look up here, that's the n is the 5, that's the 5, and this is now 4. And then this says, now times the derivative of the object. Now, let me say it a different way. And this is the way I'm going to say it throughout this tape. And if you're in my class, it's the way I talk about it all the time. Anytime you take the derivative of a parenthesis, you do the power rule of the parenthesis. That's 5, and now this is now 4, and then times the derivative of the inside. Another example. If I have this object, the power rule, the chain rule, which I could say is the same thing as the power rule, says this. This is 4 times the parenthesis to the third power times the derivative of the inside. And I just come back and copy this in. Now, if you listen closely to what I said, I did not call this one out. I did not talk about this. I said the derivative of a parenthesis to the fourth power is the power rule 4, 3, and then the derivative of the inside of the parenthesis. And then I just write that down. Again and again and again and again. The derivative of a parenthesis is the power rule times the derivative of the inside. Another way of saying that I will say many times, is always remember to take the derivative of the inside. Always remember to take the derivative of the inside. All right, let's look at several examples now. Let's start with number 19 and talking about the power rule, chain rule. Now, the derivative of y with respect to x, you must in your mind consider this as a u, as a single object. Now, I don't care whether you consider it as the letter u or what, but you've got to consider the parenthesis as an object. And you're taking the derivative of this object, and that is the power rule. 5, bring it out in front, subtract 1. And you write all that down. Then it's times the derivative of the inside, du dx. And that is what the chain rule, the power rule, is all about. Is anytime you take the derivative of a parenthesis, then you do the power rule on the parenthesis times the derivative of the inside. All right, example 20. We have y is equal to the square root of x squared plus 1. Remembering the first thing we need to write that as is x squared plus 1 to the 1/2 power. We don't have any rule for this, but if we write it as a power, a parenthesis to a power, then we use the power rule, chain rule. The power rule is I move the 1/2 down, I subtract 1 from that, and I get a minus 1, half. Okay, that's the power rule part. Then it says the derivative of the inside, which is 2x. Again, shortcut, simple statement is, anytime you take the derivative of a parenthesis, it's times the derivative of the inside. Anytime you take the derivative of a parenthesis, you do the power rule, and then times the derivative of the inside. Okay, doing the algebra now, this 2 and this 2 divide out. This minus 1/2, all this goes down to the bottom. X is left on top, and you have x over the square root of x squared plus 1. Okay, example 21. here we have y is equal to t times the square root of t squared minus 3. We have a product. We have a product. That's a product rule. Product rule, which says I can only do one at a time. Now, two things caution on this. First of all, this is a product rule, and second, it's dy dt. So, I write down the first one and take the derivative of the second one. The derivative of the second one is a parenthesis to a power. So I must use the power rule, chain rule. I move the 1/2 out in front, subtracting 1 from that, I get a minus 1/2, and then the derivative of the inside. Anytime you take the derivative of a parenthesis, it's the power rule concept, and then the derivative of the inside. Plus. Now I write down the square root and take the derivative of the first term, which is 1. And as you go into your homework, problems get more complicated. You'll have product along with division, along with the chain rule. And you have to keep these things in mind. Here's what you keep in mind. If you start out with a product, look up here, you have some object times some object. Then that's, in your mind, product rule. That says, write the first one down, take the derivative of the second one. Now when I get to this step, I say, hey, I've got a parenthesis to a power. That's chain rule. So I move the 1/2 down, subtract 1, write that down, and then times the derivative of the inside. Plus, then I continue my product rule. Write the second one down, take the derivative of the first one. All right, continuing the algebra on this. This is to the minus 1/2 power, so it moves down. This 2 and this 2 divide out. And I have t times t is t squared over this square root, plus this square root. Getting common denominator, I multiply this times this, and I get t squared plus t squared minus 3 all over the square root t squared minus 3, and simplifying. All right, next example, example 22. We have y is equal to the cube root of 5x to the 4th power. I will write that first as 5x to the 4th in parentheses to the 1/3 power. Now, I have an object in parentheses to a power. Chain rule says move this power down, subtract 1, I get a minus 2/3. Just write that down, times the derivative of the inside. And the rest of it is arithmetic. Let's go through this. I have 20x cubed on top. The 3 is on the bottom. This moves down and makes this 5x to the 4th squared cube root. Cube root of 5x to the 4th squared. Well, that is the cube root of 5 squared x to the 8th. Okay. So, the cube root of 5 squared is still 5 squared. The cube root of x to the 8th is x to the 6th times x to the 8th. The cube root of x to the 6th is x squared. So I can simplify this to x squared. That then divides in with the x cubed, and I have a final answer, as in your notes, 20x over 3 times the cube root of 5 squared x squared. Now again, the reason I'm going through this algebra is because on your homework problems, you've got to match your answers with the ones in the back of the book, and they do this type of process. So you've got to be able to handle this algebra part. The calculus is right there. That is all there is to the calculus rule. All the rest of it is algebra. All right, example 23. Now, example 23 is remembering the example 18. I'm working it a different way. What I consider a shorter method, but some students don't. I don't care which one you want to use. But on this type of problem, what I will do, if I do not have x's in the numerator, I will move that denominator, the entire denominator, up as a minus 1 power. Then I use the power chain rule. Moving the minus 1 out in front of the parentheses, subtracting 1, I get a minus 2, and then I take the derivative of the inside. Now I move this minus 2 power back down, and that leaves me a minus 1 times this. So minus 1 times 3x squared is a minus 3x squared, minus 1 times a minus 10x is a plus 10x. And as you see, you get the same answer as we got before. I personally think this is the easiest way, for me at least, to work problems like this. But it can be done by the division, the quotient rule. All right, look at that one and catch on to that one. See if you don't like to use it rather than the quotient rule. All right, let's go to example 24 and look at this one for a moment. We have y is equal to the parentheses x squared minus 3 all over x plus 1, all of that to the third power. Now what we have, forget about looking at that as some big complicated mess to start with. What we have is an object, a parenthesis, to a power. Okay, that's power chain rule. I move the power down, subtract 1, I just write that down. Then the chain rule says times the derivative on the inside. Well, the inside is a quotient, a division problem. So now I got to take the inside and work it out. So I write the denominator down times the derivative of the numerator. And we're just looking on the inside here. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. And that's all there is to the chain rule, power rule concept. The rest of it is algebra. Now what I'm going to do is this. If I have a fraction raised to a power, then I can say the numerator to that power over the denominator of that power. Then simplifying this would be 2x squared plus 2x minus x squared plus 3. Simplifying that, I have x squared plus 2x plus 3, and I have this. The reason I do this right here, the reason I do this step right here, is to be able to bring this on in to this. Let's look at now the remaining examples, number 25. Let's look at example 25 and see how to work this as another example. All right, 25 says y is equal to 1 over the square root of 1 minus 2x plus x squared. First step on this one is to move this up as a negative power. This is the object to the 1/2 power. Moving it up, we get a negative 1/2 power. Now, we have the power rule. Parenthesis to a power. We move the power out in front. Minus 1. That will make this a minus 3/2. Then times the derivative inside. Alright, now what's the algebra from here? I will move this part down to the denominator, and that will leave me, here I can factor minus 2 out, and that leaves me 1 minus x. This divides out with this, and I have left on top 1 minus x. In the denominator, I have an object to the 3/2 power. X to the 3/2 power is x times the square root of x. And so I have it written this way. Now, in the back of the book, they may have it written this way, and that's why I'm explaining this. On the homework or something else, the teacher may let you go ahead and just keep that as to the 3/2 power. But you need to know both processes. All right, let's look now at example 26. Example 26 says that y is equal to the cube root of 2ax squared. Okay, so the first step, when you have cube roots and square roots is to write this in parentheses to a power. So we now take the derivative of the parentheses to the 1/3 power, moving the 1/3 down in front, subtracting 1 here, we get a minus 2/3, and then the derivative of the inside. The derivative of the inside. Now, what's the derivative of the inside? This is x squared. X squared. That's just a constant, so it's 2 times all that. That's 4a x to the first power. Well, again, what do we do with negative exponents? Here we'll move this down to the denominator. The 3 is already down there. And that leaves us then 4ax over 3 times the cube root of 2ax squared squared. Okay? Now, what is this 2ax squared squared? That would be 2 squared, which would be 4, a squared, x to the 4th power. And that's what we have in the notes there. And I can take the cube root of the x to the 4th. I can take the cube root of x cubed out of there. And that's how I get this x out in front. And so this x divides out with this x, and we have the final answer of 4a over 3 times the cube root of 4a squared x. Again, make sure you can handle the algebra also so that you can check your answer in the back of the book. All right, now let's look at example 27, and then we'll look at example 28 to show 2 other type of problems that you deal with in this concept in your textbook, your homework, and most time you'll have 1 or 2 of these on a test problem. All right, problem 27 says, y is equal to 2u squared minus 7, and u is equal to x squared. Find dy dx. Now wait a minute, the problem says find y prime. Find dy dx. Well, this is y and u, and I've been trying to teach all this tape time that if I take the derivative here, this should be dy du. Because if I did dy dx, this would all be 0. So I can't find just dy dx right off. So what I will do is this. I will come over here and work this problem as an individual problem. This would then be the derivative of y with respect to u, which is 4u. Then I will come over and do this problem. The derivative of u with respect to x is 2x. Then, here's something you need to now learn, and it says that dy du times du dx is equal to dy dx. The concept of something like this. That's not what we're actually doing, but that's the concept that will help you know how to work this. If you can get a du on the bottom and a du on top, you can divide them out, and leaving you a dy on top and a dx on bottom. So what that says then is to go take dy du times du dx. So looking down at the next line here, dy dx is dy du times du dx, and the answer is then 8ux. Now, if you can, or if you wish, you can go back to the original problem and substitute u is equal to x squared, plug that in here where you have the u, and you have 4x squared times 2x, which is equal to 8x cubed. Well, some students will look at this and say, well, why didn't you just come back up here at the beginning and change all that to x's and then go take the derivative? Well, for 2 reasons. Number one, this is a teaching process that you need to know for more advanced calculus and other math courses. You need to know this concept for other places in calculus and other advanced work. Number 2 reason is example 28. Example 28 says y is equal to u cubed minus 1 over u. And x is equal to y cubed minus x squared plus 1. Find dy dx. Find dy dx. Well, if I take the derivative of this equation, this would be dy du. So doing dy du, that would be 3u squared. And again, here, this is the same thing as u to the minus 1. So I move the minus 1 down, and that would be a plus 1. U to the minus 2. Moving the u back down underneath. And so here's dy du. Now, doing this one is going to be dx du. And dx du is equal to 3u squared minus 2u. Well, dy du times dx du doesn't get us anywhere. Nothing divides out. We don't get dy dx, so we can't use that. Now look right here underneath these, and what we do is this. Dy du divided by dx du. When you invert and multiply, you get dy dx. That says then that you can take dy du, all of this answer, and divide it by dx du, all of this answer. And you have then dy dx. And simplifying it, you get it into 3u to the 4th plus 1, 3u to the 4th minus 2u cubed. Okay, now, you try to change that over to x. Let's go back and look at this problem at the beginning. Some students, as I said before, would like to be able to take what u is in terms of x and go plug here and get all this to be x's and then just go take dy dx. But that's not that simple in this problem. To solve this and for u, to find what u is equal to, requires solving a cubic equation. And that can be extremely difficult, if not almost impossible at times. And so here's an example of where you can use what's called the chain rule. And it comes in handy, as I said, in more advanced calculus and other math courses as you go on the way. All right, I hope now that you will study these tapes well enough to know the basic concepts of the chain rule. This is what we did last. And then before that, the quotient rule, division. Then before that, the product rule, multiplication. And then just the power rule.